Okay, so the plan for today is we're going to go over lesson 7.3, and we're going to talk about broadcasts in Android and broadcast receivers. So, in general, broadcasts in the Android world are a way to do a few things. First of all, they're a way to receive events from the operating system about what's going on with the hardware or other things in the operating system, such as knowing if your device is connected to the internet, knowing what the state of the battery is it plugged in and charging, are you on Wi-Fi or are you on cellular, and things like, has the time or the time zone been changed, has the locale been changed. There's a lot of different events that you can hook into and find out what's going on with the system using broadcasts. And the other thing we use this also for is to send and receive events between different application components, namely between activities and services and broadcast receivers. So we've talked about activities, and that's been the only application component that we've talked about up to this point. Today we'll also be touching on those additional components, namely services and broadcast receivers. Broadcast receivers, the big one we're going to look at today, is that third application component. Services we're not going to spend too much time with, honestly, this semester because of a lot of things that came in with Oreo, Android 8.0, that's meant that services are not nearly as important as they used to be. In fact, there's a lot of things you can't do with services anymore, so there's a different system that we'll learn how to use, which is how you have to do things now instead. So we'll touch on services maybe a little bit. They are still in the system, but they're very different given the changes that came with 8.0, right? So we've done a little bit of communication between components, namely we've used intents to start activities or send results back. So we said start activity or set result, on activity result. We've used that intent to send things back and forth between activities. But both services and broadcast receivers are things that kind of run work in the background. And specifically, they're used for running things when maybe the user doesn't have a UI associated with it, or while they're doing something else. So that's where, that's what we're going to be covering today, is operating system level events, but also how to send and receive these between different components. So there's three types of broadcasts that you'll see in the Android world. The first one is a system broadcast, and those are sent by the Android operating system and received by your applications. You cannot send these system broadcasts yourself. Only the Android operating system has the privileged permission to send these kinds of broadcasts. So these are going to be things like, hey, there's something up with Bluetooth or your GPS or your network. Those are going to be the things that the Android operating system sends. And so then you can write your code around that and say, when that happens, I'm going to do this in response to it. The next kind of broadcast that you'll see is what we call maybe an application broadcast, often known as a custom broadcast. And those are used to send data from one application to another application. So say something happens with your app and you want to tell the rest of the apps on your phone, hey, this happened. Do you want to do anything with it? It provides a way to communicate between multiple applications, potentially. It's one mechanism to do so. The third kind of broadcast that you'll see, which is a new thing actually in recent versions of Android, is something called a local broadcast. And a local broadcast is specifically used to send data from your app to, within the same app. Local broadcast you can't use to send data to any other applications. It's not used for getting data from the system. It's just strictly meant for getting data from one part of your application to another part of your application. And this is not a replacement for like the intents, the data that you use to start new activities. That's still going to be passed around this way. The main place this comes in is when you're communicating with other things that are running in the background, namely, to get data back and forth between background operations. So those are the three different broadcasts you're going to see: system broadcasts, application broadcasts, or local broadcasts. So in general, these are used, as I said, as a communication mechanism to send events back and forth. And so there's kind of three different scenarios that you're going to see broadcasts in. One is from the Android operating system to your application. And so that, the operating system says, here's what's happening with the hardware or the network, and you receive that in your application. And actually, this should be a one-way directional, not a two-way directional, because we don't send stuff back. So we say, okay, your app then can respond to things that are happening with the OS, and this is where those system-level broadcasts come in. They're communication between the operating system and your application, and then you also have communication between different apps, right? So those are usually application type or custom broadcasts, where one application sends them out and then another application does something with it. So for instance, if you wanted to maybe communicate with Facebook, not that Facebook uses this mechanism, but if you wanted to communicate with Facebook, you could potentially send out a notification and say Facebook could read it and do something with it, or vice versa. Facebook sends out a broadcast and you listen to it and respond to it. So those are things that could potentially happen. Is you can use it to communicate between different apps. It's one of the reasons that it exists. Another place that it exists is in communication between within your same application. So within the same application, you might have a service that's part of your application that's running stuff in the background, and you may need to communicate back and forth with that as things occur. So for instance, maybe you have a service that you're using to download a file. Okay, so you may want to start that service, tell it to work, and then later you need to know that that file has finished downloading. At that point, you would get a broadcast that would say, hey, the file is finished downloading. Or maybe you want to go get a list of products from your store, right? So you'd start that service would go off and do its thing, and eventually it would send a broadcast saying, hey, I got the products and here they are. Or other things like maybe you're watching for new news stories, right? So the service might be monitoring for that and send out a notification when there's a new story on NPR or wherever else you're monitoring. So those are the kind of the three different places that this can fit in. So as as we kind of talked about, there's a few different kinds of broadcasts. So this is usually going to be this is a system broadcast. Here we're talking about like application or custom broadcasts versus a service. This is where communication between like an activity and a service would be a local broadcast, is where we would use those things. Now, I will say in these different communication mechanisms, this middle one basically doesn't exist anymore in the modern world, or is very rare. That you're actually communicating between different apps using this mechanism. So that's one thing that a lot of things have changed. A lot of things have gone different directions. This is one that exists out there. We don't really need to concern ourselves too much about it because there are just basically better tools. There's other tools that are being used in this case if you do need that. Plus, it's kind of out of the scope of what we're doing here. It's communicating between different apps. So the two that we're focused on is this one on the left, focusing with the Android operating system, as well as with between a service and your activities, between your application. Those are the two that we're going to use the most. Of those three, really, it's going to be this one, right? This is actually the most common one. Local broadcast is the most common one that we do today. So let's dive into, how some of that fits in. So talking about system broadcasts, as I said, system broadcasts are sent by the operating system, received by your application. Any app can listen for and receive those broadcasts, even if the app is not running. That's a really important note. Is you can receive these broadcasts oftentimes, even if your app is as far as the user is concerned, not up and active. It can actually wake up your application to receive a system broadcast. So you can use this to stay up to date with different parts of the hardware state, battery, network connectivity, Wi-Fi, Bluetooth, all sorts of different things. That being said, with Android 8.0, there's been a lot of changes to how these system broadcasts work. So it used to be that you could basically receive you could register and say, I want to receive any of these large number of broadcasts, 40 plus, 100 plus different broadcasts that you could receive. And if you asked for it, it would wake your app up, and you could then handle that. With Android 8.0, a lot of the broadcasts that we used to use are actually been deprecated and changed in such a way that your app won't wake up for those things anymore. It used to be that you'd always wake up for those things, but that's not true exactly anymore. But they still can be used to get and receive events from the operating system, at least some of them, even if your app isn't running. Okay, so that has some implications. The fact that you can do it when it's not running affects performance, because that means that, hey, you could potentially have 40 apps all listing for that broadcast, and then wanting to do something when that broadcast comes out. That's a big deal in terms of performance. So it also means you have to be fast. You have to not block the UI thread for very long, because you potentially have a lot of apps wanting to do something there. And so there's that. It's also potentially you have to watch out for privacy and security and those kind of things, because, hey, here's data that any application can see, right? So if every app has permission to see, to get these broadcasts about the Wi-Fi networks, well, okay, I can get a note whenever different Wi-Fi networks are available. All right, I can go take all that list of Wi-Fi networks that are near you, send that off to my server, and a lot of clever people have figured out I can figure out your location on the globe just by knowing the Wi-Fi networks that you're near. So there's some security issues and some privacy concerns around these system broadcasts. They're helpful, but because of that, there's a lot of change and there's a lot of different directions that Android is trying to move. So there are some concerns about there, and how it works today may not be how it works in the next 3 years. Okay. So that's your system broadcasts, and again, that's going to be between the Android OS and your application. The application broadcasts, to talk about those a little bit more. Any app can publish them. Any app can publish a custom broadcast message. You just decide, here's the string that I'm going to publish, and as a good citizen, if you are going to do this, you need to prefix it with the name of your package, because these names really need to be unique among all of the apps that are installed. So you can't just say a simple word like, hey, this is the new product thing. You have to say, this is edu Ranken, PR Smith, my app dot new product, to disambiguate it as being your own app. Anytime you're sending these application broadcasts, it's worth noting that these can be received by absolutely any app that's on the device, even if the app is not running. So this can actually wake up the app. The app can say, hey, I want to listen for all of these 100 different broadcasts, and it will be woken up for every single one of those. Even if as far as the user is concerned, it looks like that application isn't running. it's worth noting that there actually are basically no security, privacy, or encryption protections around these application broadcasts.
Hey, Mr. Smith.
Yeah, yeah.
Hey, what's a typical use case for these? Like system, like this quintessential thing for system, app,
Mm-hmm.
and local.
So for system, it used to be knowing when you're connected to the internet. That used to be the primary use case for it, is knowing when you're connected to the internet or when you're offline. That is actually basically a blocked usage of it now, if that makes sense.
Okay. Yeah,
So
the apps can't see if you're connected or not.
they can, but as it stands now, they can't see if you're connected unless they're running. It used to be that you could monitor that all the time. And so what changed with Android 8.0 is you can only monitor the connectivity as long as your app is in the foreground, basically. As long as your app
Is
is
that
running.
have with some of the apps that I've downloaded, I've
Mm-hmm.
seen where it'll ask,
Mm-hmm.
can the system read the data in this app? And like the most liberal choice is
Mm-hmm.
only while the app is running, not
Mm-hmm.
all the time universally, but that's the highest level that you can take it for the system.
Yeah, there's some changes in there, but there's when we're talking about network connectivity, that's something that's changed completely. Where it used to be you could monitor for that all the time, and there's really some restrictions around that now. So basically, like the most common case for system broadcast was listening for that you're online, that you're connected to the network. What's replaced that now is Work Manager or Job Scheduler. There's a completely new way to do those kind of things where you want to say, I want to kick off a job when I'm connected to the internet. So that's what we use now instead of system broadcasts, actually. So system broadcasts are still an important thing to know, and very likely you will find if you do this professionally, you'll have some system broadcasts that you need to listen to, but they are a lot less common than they used to be. Like they used to be a core part of sending notifications, like notification that there's a new news story or a new Facebook post. Like that system broadcast of was a used to be the critical part in making that work. Does that make sense?
Yep.
So that used to be the thing, one of the things that we had to use for notifications, but we've got a new way to do that. So honestly, system broadcasts aren't used very much anymore. Application broadcasts here, so getting back to what we were talking about here, there's not really any security, there's not really any privacy, there's no encryption on these. They're all plain text. So anything you put out here as an application broadcast is public, right? Any app on your device can read that, right? So that comes with some major privacy concerns. And it also, just like with system broadcasts, anybody can read it. If you have just one poorly behaved receiver that says, "Oh, I'm going to process this, and I'm going to take a whole second to go process this," your whole operating system, your whole device is stuck for that second, right? So these can, there's a lot of performance problems with that, because it's like, okay, my app is working fine, but this other misbehaved app is causing ANRs, right? These honestly are something, unless you have multiple apps that you are using, that you are building and deploying, like your company owns 2 or 3 different apps, and you look into what there is available there to do it more securely, you really shouldn't do this. This is really not a mechanism. Like application broadcasts are basically entirely a no-no today. Okay.
Would sharing something like a photo,
Mm-hmm.
that symbol that looks like
Uh-huh.
I don't know, like grapes or like a pawn shop symbol,
Okay.
is that an example of when you would use an application broadcast? I would send something from
No,
Google Photos to an email, for example.
it's not. It's not.
Okay. Okay.
That is actually a case where you're still using regular explicit and implicit intents to start an activity. That is not a broadcast. So that's you just saying, hey, I want to share this, And so like you use that share compat thing. That's just your regular explicit and implicit intents that we talked about with activities. So that doesn't go over broadcast. So yeah, there's what I will say in terms of the application broadcast. Basically, we don't use these ever because it's just too much of a security and a privacy problem. That again, the only use case for them is if you say you have 2 or 3 different apps that need to talk to each other. That's the one place where this becomes useful. But that is well beyond the scope of what we're going to talk about here. Okay? Plus, there's other mechanisms that you can use for that, which are better. So, next up would be the local broadcasts. And as I mentioned, the most common case for this is communication between services and activities. Right? So you say, hey, I want to go get something from the network. You spin up a service that does that work in the background, and then it lets it send a broadcast when it's done. Cool?
Yeah, this would be the download notification. That's your quintessential case, right?
Yeah, that's one case. But even just simple things like, hey, you want to go to Facebook and get your Facebook feed, right? That actually would likely go over this. That would still be, that would be a basic use case. So more than likely, like anywhere that you see like a list of things being shown up, it's very likely that this is occurring, that you're using these local broadcasts. So basically, whereas the others are a little bit more niche, local broadcasts you're probably going to use in every app that you create. Suffice to say. Because that communication between services, every app you write pretty much is going to have services. Because at some point it's going to need to connect to the internet or just show notifications. And for both of those is where you need these local broadcasts. So they can only be sent so local broadcasts can only be sent and received by the same app. And they can only be sent and received while your app is quote unquote running. So, because there can only be sent and received by the same application, they don't leak out the extra into the ecosystem of all the other apps that are running. They're much more secure, and they don't cause all the performance issues that general system-wide broadcasts do. So that's why we pretty much stick with these entirely, because we can control them. And it's like, okay, I know how this is going to work because I'm just talking to myself. I'm not shouting and talking to everybody else on the system. So, whereas the application broadcast, and I was saying, don't use these at all. These are definitely things that like absolutely use local broadcasts. They are great. They are terrific. They're a beautiful tool in your tool bucket. These are things that, take a note on the local broadcasts. They're going to take a little bit of time for us to put the necessary foundation into place. It's going to take a few lessons before we can come back to this and really give these local broadcasts the attention that they deserve. So do keep that a little bit on the back burner, because over the next 2 weeks we'll be talking about a lot of the foundation stuff that goes into services and the job scheduler and things like that. So and notifications, because then we'll come back and we'll build these into a more full-fledged application. So in terms of the world of Android, in terms of actually implementing this and turning it into code, the first class you need to know about is the broadcast receiver. A broadcast receiver is an object that responds to broadcasts. Oftentimes you can just kind of think of it as a listener, but it listens for like system events or events from another application component, whereas like the click listeners listen for when you like click on a button or interact with the UI. So a broadcast receiver is to receive other events, basically from other parts of the system. So broadcast receiver is that base class that you have to subclass and say, here's the work I want to do when I receive a broadcast. So if we're setting up these, you're going to see broadcast receivers around in different places. The next thing that's worth mentioning, I kind of mentioned this term service already. A service is used to run code, quote unquote, in the background. That's at least its goal, and typically without a UI. So a service is typically running stuff in the background, like downloading files or making network requests, while the user is usually doing something else. Now, they can also be used for things like media streaming. So if you have like you're listening to your music or you're watching video, there may also be a service there involved that is fetching, the next piece of audio or the next piece of video and things like that. So services can be used for a lot of different things in the background. Notifications is probably I would say the most common use of a service, is for checking for new data and other things that you may want to get notified about. Okay, so those are just some general terms there. Side note, yes, it's meant to do things on the background. Both broadcast receivers and services do not run on the background by default. They actually run on the UI thread unless you tell them to run on another thread. So you still have to use some of the tools that we learned about, like async task or threads in general, executors. There's a lot of multi-threading tools that you can use to run things on a worker thread, but you do have to use those tools should you want to move it off the UI thread, which you usually do.
Yeah, I was just going to say that sounds like poor default design.
Yeah, well, it is what it is. I wish that it wasn't that case, but basically what it means is that you have a short window of time where you can do setup stuff on the UI thread, and then you have to get off of it and let the rest of the work happen on another thread. But yeah, that just is how they've set it up. I think the reason that they've done it that way is in terms of synchronization, to make sure that there's like a predictable sequence of events. Because if they ran things on a background thread, then the order of things would not be as predictable. It might be a lot more random. So that's part of why that is the case, is to keep and preserve a predictable order to things. So there are a few different ways to register a receiver to say that I am interested in receiving broadcasts. And so one of the ways that you can register a receiver for either system broadcasts or application broadcasts is in your manifest. So that I can declare a receiver just like I can declare like an activity. I declare an activity in the manifest. I can declare a receiver in the manifest. Those are then basically statically set up, and these will trigger even if your application is not running at the time. So that's how you get broadcasts. It's like, hey, my application is not running. I still can get those broadcasts. My application will still be woken up for those. Some of these broadcasts, in order to register them in the manifest, you also need additional permissions. So like if you want to receive an event that's saying the operating system that the Android booted up, there's a boot completed event, but you have to have a special permission in your manifest to say, I can do that. If you don't have that permission, then you don't get that broadcast. So there's a few different ones in the system where you need a permission to be able to listen for it. There's also, as of 7.0 and especially 8.0, there's most of the broadcasts can't actually be received this way. So there is a short list of exceptions. I'd say it's 20 to 40 different broadcasts that you can still receive through a static receiver like this, connected, set up in the manifest. But most system broadcasts you can't actually listen for this anymore if you're on 8.0 or greater. Okay. So, what code do we need to put into the manifest in order to make this work? So, like with an activity, we create and add an activity tag. Well, we add a receiver tag to the manifest. So receiver tag, android.name, this points to the class that's going to implement that receiver. So I say this is going to point to my global receiver is what I've named the class. And I'm also going to say that it is exported is true. Exported true means that it can receive broadcasts from outside of our application. So if you're registering something for system broadcasts or application broadcasts, typically you're going to need that because those are not coming from your application. So that makes it accessible to receive broadcasts from the outside world. So exported is true. Inside of that, we've got an intent filter. Now, intent filters we've seen before. Intent filters we added for when we were working with implicit intents. So we said, hey, I want to start this activity. This activity is available. If, for instance, you want to view a picture, then we would declare, that we want the action view action. So the system for receivers follows a very similar syntax, but it's not the same. It's not the same list of actions. So there's a list of actions that you can receive in activities in terms of implicit intents. There's a separate list of actions that you can receive as broadcasts. So I can't, for instance, say I want to receive the action view intent as a broadcast. That's only available as an activity, as an implicit intent in the activity. Similarly, like boot completed, I can only receive as a broadcast. So in here, in this intent filter, you can say, here's all of the actions that I want to receive. I'm interested in all of these. So here I'm saying I want boot completed, time set, time zone change, action power connected, action power disconnected. So I've got 5 different things that my receiver is listening for. That can be as big or as large, big or as small as you need it. Just throw in whatever intents you're interested in hearing about. Okay. So that's what we need to do to set up in the manifest. Going with that, you see we've got this global receiver declared there. I also need to implement that actual receiver in Java to tell it what to do when we get those actions. So here I'm creating a class, public class, global receiver. Important thing here is that it extends the broadcast receiver class, right? So I'm saying this extends broadcast receiver, and then I need to override the onReceive method. So the onReceive method was what gets called when you receive a broadcast. So that's where all your actual interesting logic goes, is you say, when I receive a broadcast, I'm going to do something with it. And oftentimes you need to know what action it was. So for instance here, remember I've got linked up to 5 different actions. I may need to do something different based on the action you receive. So typically what you'll see in here is we'll do a switch statement based on the action. So if it's this action, then do this. If it's this action, then do this. If it's this other action, then we do that. So we usually set up this as a big switch statement for the different actions we're interested in.
Is this in a separate file? Sorry, is this a separate file?
Yes. So if you're setting up a receiver this way, this will be in a separate file. So like global receiver will be in globalreceiver.java. Cool?
Yeah.
Yeah. So this is a separate file. The next thing we're going to talk about is how to set up receivers at runtime. So not binding them, setting up in the manifest, but setting them up at runtime, typically when you get to a particular activity. So it only is listening or receiving those broadcasts as long as you are on that activity, and stops receiving when you leave it. So you can register that at runtime. And these, we'll talk about, this is where these receivers, if you're registering at runtime, are usually not a separate file. If you're registering them globally, statically in the manifest, then it does need to be a separate file, but we typically don't do that with runtime receivers. So these runtime receivers can be registered in in an activity, within an activity, or they can be registered within a service context. You can do them in either way. The most common one of those two is going to be the activity. So Doing this allows you to register and unregister your receiver as dynamically as you need it. And this is tremendously helpful for performance because it means that you're only receiving those broadcasts when you're actually on that activity, when it's actually started and running. So this is like the way most of the time if you're receiving a system broadcast, you probably want to do it as a runtime receiver instead of a global receiver. It used to be that this pattern of setting things up in the manifest and setting them up globally was the most common use case that you'd see out there for receivers. But nowadays, this pattern here of global receivers is actually pretty rare, and it is not something you should do most of the time. So usually it's going to be a dynamically running receiver rather than a statically set up one. So it's usually going to be this. So code kind of needed for setting up a dynamic receiver like this. So we're looking at an activity. The first things I want to set up is a two fields up here. So I have a field for my receiver, and I have also a field for my intent filter. The reason I'm putting those as instance variables is that way I can reuse them and not recreate them. And that's kind of important, again, in terms of a performance perspective. So in terms of onCreate, I'm going to create onCreate is where I'm going to create both that receiver and that intent filter. So to create the receiver here, I'm just creating it as an anonymous class. That usually ends up being kind of the easiest way to set it up and run. So inside of there, I'm going to say, well, let's create a new broadcast receiver. I'm going to override the onReceive method and then put whatever logic I need in here. Over time, these tend to grow a little bit big, so what's in your onReceive method tends to get pretty large. So what I do in here is usually just move it over to another function and just say when I get the onReceive, let's just call another function to do that. And I just say that oftentimes will end up meaning that there's just one line here that just passes the intent, which is the data, to another method. So that's usually all you end up having there is just the one line of code inside of onReceive. The intent filter, to create an intent filter, you just say new intent filter, and then you just add actions as you need them. So for instance, here I'm adding two actions. I say I want to hear about connected when the charging cord is connected or when it's disconnected. So I'm asking for those two, putting that in the intent filter. And so you just kind of do that until you have as many intents in there as different actions as wherever you need. So those two things I create in onCreate, so I can reuse them later because I only really need to create those once, at least per activity on a per activity basis. And then down in onStart, typically that's where you want to do the actual registering. Sometimes it makes sense to register the receiver in onCreate, depending on what you're doing. But most of the time, it's better in terms of performance to just wait to register the receiver until it starts. And that means that if the user goes and leaves your app and is using another app, that it's not spending time with those broadcasts. It's only spending that time when you're actually looking at the application. So we register the receiver here, providing the receiver plus the intent filter. So remember, the receiver kind of tells it, here's what I want to do when I get the broadcast, and the intent filter says, here's the broadcast I want to get. And then finally in onStop, you're going to unregister it. So that's the pattern that you'll see for these dynamically hooked up receivers is, you start by creating them in onCreate, and then you register and unregister them in onStart and onStop. Okay. Any questions right now?
Yeah, your code here, is it typically a lot of lines of code that you put in there, or is this pretty light? I'm trying to weigh this compared to other things we've learned. Like, I consider what we've learned to this point, recycler view, to be the big thing, the 800-pound gorilla. Where does this one fit in?
Not that big. As you can see, I mean, basically all of this code here that I've got right? This isn't in an activity. I'm not creating separate classes for this. So the things that, what I'm showing here is kind of those are kind of the fixed parts. That's the pattern. This is the recipe that you use. What usually ends up taking up the most code is this part that you write into on receive, which is, well, what you want to do when you get the broadcast, right? And that really depends on what kind of broadcasts you're receiving and what your use case is. Why do you need to receive that broadcast, and what do you need to do with it? So most of the code of this actually goes into that on receive method. Okay.
On receive, where is that? Oh, okay. Man, all right.
Yeah. So most of the code will end up being in here, right? And I will say that, I have not, it's not unusual for this to grow to 100, 200 lines of code that you need to do in response to broadcasts. That's not unusual. So there may be an awful lot of code in response to this, but the code that we're seeing here is just the code to set it up. Okay.
Right.
Set it up and tear it down. So next up, let's talk a little bit about local broadcasts. So local broadcast receivers cannot be registered in the manifest. You have to register them dynamically. You have to register in their runtime. So your receivers can be registered in a activity or a service, just like you can register your regular system broadcasts in an activity or a service. But they can't be registered in the manifest. If you're using a local broadcast, you cannot register it in a manifest. So that's reserved specifically for those system broadcasts. So in order to send a local broadcast, which is really the only kind of broadcast that you'll be sending as local broadcasts, first thing first, you need to get the broadcast manager. Typically, you're going to do this in the onCreate method. And so you're going to say, okay, well, let's call local broadcast manager.get instance. This takes a context, which if you're in a service or an activity, that'll be this, because both of those are contexts. So you're just going to say, let's get the local broadcast manager. Usually say get that in onCreate, so I have it later and I don't have to keep getting it. And then when I actually have something interesting that happens, then I'm going to send the broadcast. And so in order to send the broadcast, I'm going to build up an intent. And this is actually an implicit intent, just like we've seen before. So I say new intent, give it a string that represents the action. So here I'm referencing a constant action foobar. So that's the action that we're sending out. And then I can add extras to it, just like I would, with other things that we've done with other intents. So I can add an extra foo, extra bar. Those can be wherever types I want, just like you can do with activity, sending data around between activities. So we put some data in, and then we're going to call local broadcast send broadcast. So we just say, here's an intent, build it up, send it off. It will then be received somewhere else. So one part of your code, you're going to say, hey, here's a broadcast, send it out. Somewhere else, you're going to receive it. So the way you receive it actually looks very similar to how we received our system broadcasts. We need to first get the local broadcast manager. We also need to build up a receiver. So just like we did with other things, we build up a receiver, create an intent filter. So that intent filter will say, hey, I want to receive my action foobar thing that I declared. And so it's like, okay, I want to find out when foobar happens. And so this part, those three sections are typically going to be in your onCreate method. And then in onStart, you would say, well, let's register a receiver, and onStop will unregister it. So it's a very similar pattern to the dynamic system broadcasts. The only difference here is we call local broadcast manager dot register receiver and local broadcast manager dot unregister. With system broadcasts, we just call it on a context. So we'd say context dot register receiver, context dot unregister. So we're really just calling on a different object. but local broadcasts and system broadcasts share almost the same identical code. Cool. Any questions on the code? Okay. So let's look at some sample applications. I'm actually gonna, I don't think I'll pull up all of these. These are all available in that same repo that we used on, was it Tuesday? No, Wednesday. Same repo that we looked at in Wednesday. So these are in my Android Code Labs completed repo. So the first one we'll look at is this global receiver app. And we can kind of see this in action. So I'm going to pull up that global receiver. I'm actually going to run this on API 21. And so what I've said in the manifest for this global receiver project is that I want to say, hey, let's receive a bunch of different events. So here I've got a receiver that's registered, and I say I want to receive when all these different things happen. So boot completed, screen on, screen off, time set, time zone, locale, power connected, power disconnected, power changed, low, okay, and connectivity change. So this is kind of what we're going to be looking at here. I'm going to go ahead and post just as a reminder, I'll post the link here in GitHub and give people a chance to pull this up. So there's a link in the Discord to where those are located. And so we'll be looking under 7.3. You'll find that there's a few different example projects there.
We can just pull it down if we already have the repo in our.
Yep.
Yeah.
Yep. If you have the repo already, you can just pull again, and we'll have it. Okay, so should you need to hook up a receiver like this yourself, the way to create a new receiver as a separate component, a separate class like this, is you right-click on the package and we go to New. And you remember previously we've gone to like Activity, and you can create a new empty activity that way. If you scroll on down, you won't see a folder in here that specifically says Receiver. Because receiver is all the way down here in other. So if you do want to create a receiver, that's how you go in a global receiver like this. That's what you do, is you go down to new, other, broadcast receiver. And so if I create that, it'll kind of ask me, well, what do I want to name it? I'm just going to leave it as my receiver. I can mark it as exported or enabled. I'm going to leave both of those boxes checked and hit finish, add. Okay, cool. So I've got an empty, broadcast receiver called my receiver. You can see it started by putting the onReceive method in there, and it's actually gone and updated the manifest as well to automatically put the receiver tag in. So should you need to make a global receiver or a static receiver, that's how you do it. You won't need to do that for the labs because I've just asked you to use a dynamic receiver for that lab. But that's how you would do it if you needed to. Cool?
Can you go over how to make that again?
So you're going to right-click, say New, Other, Broadcast Receiver.
Oh, okay.
Yeah. So it's buried down there under the Other category. All right, so I'm going to go ahead and delete the receiver because I don't need it. Delete anyway, and I went ahead and deleted it from the manifest as well. Okay, so that's kind of where it starts. You declare this in here. And so I've got a pretty simple receiver. I just told it to do two things. I told it anytime it receives a broadcast, it's going to log that first to Logcat, and then it's also going to show a toast, right? So if anything happens, anything that it cares about, that's all it's doing, is it's logging and showing a toast. Okay, so that's what's happening with that global receiver. If I then go to change some things, so you can go to actually change some settings on the device. So I'm going to go like the triple dot here, go to more. And as you're testing things with the system here, it tends to be pretty helpful to actually will change the state of the device. So for instance, maybe I want to change the battery level. Okay, so let me go in here, and there's a battery section. I can push the charge level down, and you can see as that changes, I'm receiving that battery change broadcast, right? So I could respond to that and maybe update something on the screen to say, hey, you're at, you're 50% charged, or maybe you get all the way down and you're like 5% and say, hey, careful, your battery's almost out, and I might stop doing things like using the network, right? I could potentially say, well, if the charge is low, then let's stop, let's only do things with the internet if you have, X amount of charge, if you're at 20% or higher. I can also change whether or not you're currently charging. So here, charger connection type, I'm set to AC. If I switch that to none, you'll see I get the power disconnected event. If I plug it in, get the connected event. So if you're doing this on your physical device, you can actually unplug and plug the cable, and you'll see that toast pop up. So that's really interesting. Now,
so you really do need the emulator. I mean, that's absolutely, well, not absolutely, but pretty close to indispensable here.
Yeah, for certain things like this. Like I can't, on a physical device, I can't just change the battery level by sliding a slider, right? I have to actually wait for it to drain. So testing things with the battery is definitely something you need to do on the emulator. You can do it somewhat on the device, but it's much harder there. So those are there's a lot of different controls in there that you can change. The next one I wanted to point out, maybe under, cellular. So let's say I want to say, well, what happens if the network gets connected? I'm going to go into cellular. Under data status, it's set to home right now. If I go down to unregistered or off, what will happen is it'll actually look and see as if it's disconnected from the network. So we should in there get, in theory at least, a disconnected event, but I think that it's not appearing. Okay, well, let me go back up to home. Another way to trigger that is if I go into airplane mode. So for instance, I can toggle airplane mode up here. So we're in airplane mode, and you see the connectivity changed. Okay, so it saw that it's disconnected from the network. I can go back in. If I want to turn off the basically it's here as a 4G, I could also just do that by toggling this switch. So if I turn that off, we're now not connected to the internet. I can turn that back on, and we would be connected to the internet. So you can get and respond to that. Now, one thing that's worth noting here, the two things I'm doing are logging and I'm showing toasts. Both of those things actually can happen. Logging, writing log messages, and showing toasts. Both of those you can actually do even while your app's not running. Okay. So one of the things that I've said in here is I've said in my manifest that I want to listen for when the time or the time zone is changed, right? So let me go to here. I'm going to hit the little square button. And my app's not running, right? Everybody with me there?
Yep.
So my application's not running. Now watch what happens. I'm going to go into the settings. And this is a different place because I'm on API 21. So it looks a little bit different on your physical device because they're API 30. So in here, I'm going to uncheck automatic date and time, automatic time zone, because previously it was picking those up automatically. Watch what happens when I change the date. I'm going to change it to the 9th. Android, where did that toast come from? Well, that toast came from my application, right? And that toast actually fired, even though, as far as the user is concerned, right, that app's not running, right? If I look at my running apps, that one will not appear. Why is that? Back to settings. Yeah. So I changed the date, and that, you know, it's showing up a toast. If I change the time zone, I can change it to that. You can see I'm receiving that time zone change event, even though, right, as far as the user is concerned, that app's not even there. Is everybody following with me? So what happens if I say I'm a misbehaved app, and I go in here and I say, well, I'm going to try and do something long running and block the main thread in response to that toast. So I'm going to go in here and I'm going to say thread sleep, and let's just sleep for 10 seconds. Right, so I'm going to say thread sleep 10,000 in my receiver. All right, let's go run that code. Okay, I'm going to hop back over settings, and let's try to change the date again. Change to the 1st. Okay, looks like I can still use the application. It looks like it's going to maybe take some time for that toast to show up. Okay. So there's maybe been some changes. So that you know, would have blocked other broadcasts, but I guess it didn't block the UI thread, which is interesting. Usually it does. So I'm going to pull that on out. Okay, but either way, so you can use that as a way to receive events again when your application is not running. That's what the global receiver, you know, your static receiver is about. It's worth noting that if you run this on API 30, a lot of these events won't trigger. So if I'm running this right now and I'm maybe get out of here and I try to change the battery level, you will see that I get those from that global receiver. But if I were to run this on API 30, some of those things will not work. So, for instance, let me, again, leave the application and try to change the battery, right? So I'm going to go to here, go AC connected. We'll notice that the power connected device message didn't show up, right? So there's some events now, API as of API 8 and later, that you actually can't receive as system broadcasts. So very with me there. So you can only receive them dynamically. So another thing that's in this app. Let me actually close this and go back to API 30 now. So let's say in here I've got in main activity, I've also got a receiver that I'm registering dynamically. So I created an onCreate, I register all these different events. I say, well, let's register it on create and unregister it in on destroy. So as long as that activity is around, it will automatically change those. So, you know, what am I doing? Well, I'm just logging it and logging in and updating the text to show that. And you'll notice that nearly always it says connectivity change because connectivity change fires an awful lot in the Android world. Okay. Any questions on this app? You can understand how that fits in, how to set up global receivers? So I'm going to go over to the battery status app. And so what I've set this one up is that it's just going to show an icon, represents the current state of the battery and whether or not you're charging. So I start it up right now and it shows that way. If I go in and adjust the battery, adjust that slider, you'll see that it changes the text view here. And it goes, the image changes as well. And I'm actually using a kind of image in here called a level list, where you can kind of tell it, here's the level of the image, and it will automatically switch between different icons. So that's how that operates. And then I can say, well, let's have it be connected or disconnected. And as you can see, I'm showing a stack bar there. So those are things you can do. All of this is set up with dynamic receivers. So in this context, I set up this broadcast receiver, but you'll notice there's enough code in this particular example, and this usually happens, where it didn't make sense anymore for me to keep it inside of the broadcast receiver. So I made this other method called onBatteryChanged, right? So I just say, well, I'll handle it over in this other method to keep my onCreate method pretty short. Does that make sense?
Yep.
So over an onBatteryChanged, because I've registered the 3 different listeners, connected, disconnected, changed, I'm handling those 3 with switch case. So I say, let's switch on the action. And so if it's connected, I'll run this code. If it's disconnected, then I'll do this. Or if it's a battery level change, then we'll do some different logic, right? So that's where I'm showing a snack bar for connected and disconnected, and then I'm updating this level in the text based on that state information. So that's one of those things you can do is monitor the battery level using those broadcast receivers. Questions?
Nothing too specific. I see your string format there with the double percentage.
Yeah.
What is that briefly?
So this right here, I'm escaping the percent. So just like 2 slashes says I want to put a slash there, two percentages says I actually want a percent there. So you can see it's 100%, right? This percentage, that's the 2% civils.
Oh, what if it was something besides a percent? What would you do?
Well, then I probably don't need to escape it.
Oh, okay. All right. Yeah. Makes sense. I got it.
Because in a format string, the percent is special, right? So percent 2D is how I'm formatting the number, and then that's the percentage sign that comes after it, and then obviously percent %s is the string. So I say it's charging or not charging, depending on whether it's connected to the wall. So looking at some other examples, I think the network status, if you want to look at that, it's basically just monitoring, what's the signal strength of your Wi-Fi and your cellular. You can play around with that yourself. And then I've got another one in here called local broadcasts, which shows you one way that you can set this up. So here in this case, I've got a service that's running in the background, and I've got an activity that's kind of running in the foreground, and those two are communicating. So what the service is doing is it's basically just, it gets started up, and then it's just tracking how much time has elapsed. And so every second it's sending out a broadcast to say this is the current time. And so my activity is receiving that. So that's an example you can kind of look at and see how do we do this communication between the services and activities. There's honestly a lot of stuff, as I kind of said, there's a lot of things we still have to build up. So there's a lot of things in this local broadcast example that you'll see we haven't discussed yet, and that's okay, because I'm not asking you to do anything with local broadcasts yet. But that's to give you an example of how that can happen. Okay? Any questions right now?
Nothing yet. Just gotta play around with it later.
Okay. Anybody else? Feeling good about the material?
Yep.
So as far as your labs for this is concerned, I've updated the worksheet on Inside Ranken. So your problem is pretty simple. Basically, you're going to set up a small app that's going to listen for, an event, namely whether the headset plug is plugged in or not. So that's your lab for today. I don't think that should take you very long. This lecture is pretty short, so my expectation is that you finish that lab today. I'm not setting aside a separate lab day for that. So, because Monday I'm planning to start right into 7.2. Cool?
Yeah. So just head off on our own, start working on these, and you'll be available for questions.
Yep, I'll be right around for questions. So, my slides are up on Perusal. This worksheet's up on Inside Ranken. So, yep. That's it. That's your lab for today. And as usual, reading assignments up on Perusal. So reading assignment and the lab, and then I'll see you on Monday.
Right on. All right. Have a good weekend. Thanks, Mr. Smith.
No problem.
Appreciate you.
See you later.